Hi guys, in this video we'll learn how to measure a force. We know that force has two visible results. One, it can change the shape of an object, and two, it can change the state of motion of an object. It brings an object into motion and it can stop a moving object. We have already studied one method of measuring force in part 1. In the first part, we measured the force depending on its ability to distort objects. Now, we'll study how force can change the motion of an object, and from that study, we'll devise a method to measure the amount of force. We know that a force can change the state of motion of an object. It can bring objects into motion from rest and can bring objects into rest from motion. Or force can increase or decrease the velocity if it is applied to a moving object. Or force can change the direction of motion of a moving object. For the second method, we need a clear understanding of velocity, which is another vector quantity. We also need to understand the mass or inertia of an object. Let's take an object of 1 kilogram mass, and to avoid complicacy, we ignore friction and air resistance. In real life, we see that on a smooth surface, an object can be moved easily or with less amount of force, and a moving object keeps moving for a longer period of time. Objects at rest resist more to move on a rough surface, and a moving object comes to rest sooner on a rough surface. This is due to frictional force. The frictional force is a special type of force that occurs on the surface where an object is touching and tries to move. We will discuss frictional force in a separate video. Air also pushes back a moving object. Therefore, the surface on which an object is moving and the environment where the movement is taking place have an impact on the motion and force. To avoid these complications, we will consider a frictionless surface and an environment without air. This way, we can concentrate only on the force we are applying. We know that force can change the state of motion of an object. Let's consider the 1 kilogram object is at rest. Now we apply a force on the block with a machine. Let's assume the force application is instantaneous and happens for 1 second. The force, for this time, acts through the center of mass. After the force is applied, the object starts moving with a velocity of 1 meter per second in the direction of the force applied. After this 1 second, the object will be running every 1 meter in every 1 second. Now, we keep increasing the amount of force in the same direction. We will see that different amounts of forces are resulting in different end velocities. If we keep applying the same force for a longer time, the end velocity will be different for the same amount of force. For our purpose, we will apply each force for 1 second only. Let's say one force F1 results in 1 meter per second velocity, F2 results in 2 meter per second velocity, F3 results in 3 meter per second final velocity, and so on. From the results, we can compare the forces and can say F1 less than F2 less than F3. From these results, we define a unit force. A force that acts on a body of 1 kilogram mass at rest for 1 second and creates 1 meter per second final velocity is a unit force. If the force is applied on a moving body of 1 kilogram and 1 meter per second velocity but to the opposite direction of velocity, and it stops the motion in 1 second, this will be a unit force too. Unit force is named as 1N, which is 1 Newton. The actual unit is 1 kgms inverse 2, and after Sir Isaac Newton, it was named Newton. Therefore, a force resulting in an end velocity of 3 meter per second after 1 second, which was applied on a 1 kilogram mass, is 3N. And a force resulting in an end velocity of 10 meter per second velocity after 1 second is 10N. Now, if we change the object, the result of the same force will be different. If we take an object of 3 kilograms and apply 1N force on it, the resulting velocity will be 0.333 meters per second. If the force is applied for 1 second, this will be discussed in detail in the video for Newton's second law of motion. For now, we have at least learned a method of measuring the force from studying one of its properties. From these two discussed methods, in Part 1 and Part 2, we can measure a force from its different effects on an object, but the discussion of force is much more elaborate. from its different aspects, Sir Isaac Newton formulated 3 distinct laws of motion, which are called Newton's laws of motion. These laws are heavily dependent on Galileo's laws of falling bodies. We'll be creating different videos for each of these, so keep an eye on the channel and subscribe to it.